Welcome back to Databytez, your source for data-driven principles. We are back on another technical topic, this time covering the n-dimensional array and continuing with the subject matter of data structures. And so returning back to our handy-dandy IDE running Python here, we are creating an n-dimensional array with NumPy. That is really where n-dimensional arrays are born from. Now some might consider it not really a data structure per se. If you remember our what are data structures and what are important video, why are they important? They weren't listed here, but I like to consider them something different because they work a bit differently than the array that's normally conceptualized. And that because we can start working with dimensions, and dimensions are important in data. Some things require certain dimensions to function. We're not going to think about it explicitly, but for instance, whenever you might upload something, I remember there was something that you have to upload for the state of New York. If you were a franchisor, meaning you gave out franchise license, you need to report on it, and the report required certain columns, and we can consider those columns dimensions. And so those needed to be in certain formats. So these dimensions had certain formatting requirements. It's kind of abstracting, not looking so literally here. Kind of just saying, oh, it's a n by m array, and it has certain rules about what data types or how the data can be formatted within each one of those columns. So not focusing on New York specifically, let's create our first n-dimensional array. So we can kind of view it here, and it kind of looks like a normal table here. We have 1, 2, 3, 4, 5, 6, and this would be considered a 4 by 5 array. So we can print it here. We can print the shape. See, 4 and 5, 4 by 5 array. And of the type, it is a class NumPy ND array. Now that's all great and dandy, but now the real exciting part is that we can start working in 3 dimensions and even higher dimensions, but it's not really easy to conceptualize at that point. But we can make a 3-dimensional array. And this is best done physically with some blocks, and we'll kind of get into that. These are also, fun fact, that ND arrays are also tensors. So there's a tendency in data, and because it bleeds through with different subjects like mathematics and stuff, different things have different names, but they're all really the same thing. So this kind of original one that we're going through here, where it's like the 4 by 5 matrix, is known as a rank 2 tensor. This 3-dimensional ND array is known as a rank 3 tensor. So it is still the same type, so it doesn't matter how many dimensions we really put in. It's still a class ND array, but when we print the shape, now we have 3 by 3 by 3. Now, important thing about our ND array here is that the dimensions need to be, the fun word again, homogeneous. They all need to be 3 by 3. We cannot have a missing value. Or no, it's going to be like, hey, what are you doing? Inhomogeneous shape after 2 dimensions, after the second matrix here. Something's wrong. Detected shape was 3 plus 3 plus inhomogeneous part. So that's why we need to always make sure we are going with the same dimensions. If not, I think we might be able to leave it blank, but it might still be upset. Yeah, no, it needs an element. So we need to make sure there's some kind of element here at all times, because again, I'm going to make another video on this just because I think it's easier to conceptualize this with physical things with our hands, being able to see it. too much in abstractness can kind of make things hard to really grasp sometimes. There's like these little blocks that you might have used to learn multiplication tables. So you're like, oh, one sheet was 100, 3 sheets was 300. Well, you can think about those sheets as the matrices that comprise the 3-dimensional array. You stack 3 of them together, those 300, and that is your tensor. So you're being able to say, hey, I want to pull an index out here, is pulling out a consistent matrix. Now, this can be a bit hard to read, but we can look at the comments here to kind of see here. So if I were to pull out the first sheet, the first matrix, I would get the 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is what I'm going to print here. There it is. If I wanted to pull out the second sheet, I would get the 10, 11, 12. And there it is. And of course, third sheet. And so as I go through each dimension, I am pulling out an entire sheet to get these tables. On the contrary, if I were to print out, let's print. What do you think I would get? If I were to pull out now from our 2-dimensional array, our 2-dimensional ND array, our tensor rank 2 array matrix, what would I get by calling out the first one? Would I get a row, a column, or a value? The answer is a row. Now, there's more to slicing. We can, of course, pull out a single one. And this is kind of like, think about the coordinate plane. If I were to think about it as an XY matrix, this would be what would you think it'd be? 1. And because we're dealing in 3 dimensions here, if I were to put 0, 0, 0, I would get, take a guess, 1. And if I were to make the first one 1, what would that be? 10. So again, it takes a bit of thinking. It took me a little bit to kind of wrap my head around this kind of dimensionality. And once we start really going past 3 dimensions, I don't think it's really easy for us any of us to really work with that. It just becomes too abstract. And fun fact, if we try to visualize the array the same way, it can't really do it. So instead of looking at a 3-dimensional object, our IDE here just pulls out the first sheet, the first matrix, and works with that. Can't really work with 3 dimensions the same way. And here you can see it's calling 0. You can call 1 instead if you wanted to do that, but it can't visualize all 3 at once. So that is the Pythonic, the general programming language way of dealing with n-dimensional arrays. NumPy is the way to go. But let us now look at Excel. Now, Excel does not have ND arrays naturally. It works with flat tables, but that doesn't mean we can't kind of simulate the behavior. So kind of building on the idea of dictionaries, and really you can kind of look at this as an advanced application of dictionaries here as well, but I like to call it its own thing. I really want to separate the two in the way that we deal with it in Excel. We have different keys, or you can even look at this as dimensions, dimension 1, dimension 2, dimension 3, and then a column, and then a series of arrays here with 3 columns that we're just calling dim1, dim2, dim3. So we can use, again, the switch function that was in our previous videos that made an appearance to pull out these different arrays. And again, that ends up simulating our n-dimensional arrays. It's not exact, it's not native, but the idea is still the same. We can stack multiple tables. Maybe it's a different country and we want to pull out a different table as a result. They have the same dimensions. Like let's say you're dealing with a company that operates internationally, that has different SKUs, products, and sales and whatever, and you want to do certain calculations that depend on a key searching of the country. So this might be US, think of this as B as Germany, C as Japan. And so it's like, oh, I want to do something once I get Japan, but I want to pull out those tables. Here I'm able to do so. And then I can feed this array into another function that takes arrays such as filter, because if we were to write out filter, there's an array here, maybe filter that down a bit more based on some of the criteria that we have, and then do further calculations that way. So it's good to know, again, based on the problem that you're dealing with, how you can leverage these data structures to solve it, probably trivializing a problem. The theme of the hour here is that choosing the right data structure for the right problem can make solving it a lot easier to whatever algorithm you're feeding. And again, an algorithm is just a series of steps. Systematic steps that are followed each and every time. So that covers our discussion on n-dimensional arrays. If you feel that you want more on this topic, try to understand it, feel free to let me know in the comments below. But if not, that's it. Hope you have a great rest of your day. Until the next time, stay tuned because we're actually covering a bonus data structure on our next video. We're covering tables. Now that is not part of the normal discussion when it comes to data structures, but I feel personally that it deserves its own discussion because in the most common thing that we use, which is not a programming language but Excel, it treats it as in its own object and as a result its own structure. So I feel like it's worth talking about. But again, that's next time. Have a great rest of your day. Have a good one.